The region R is bounded by the curve y equals sine x, the x-axis, and the lines x equals pi over 6 and x equals pi over 3. Find the volume generated when R is rotated through 4 right angles about the x-axis. Give your answer correct to 3 decimal places. So I've got a summary of the question here. So let's have a little look at this then. Find the volume generated. So I'll just do a little sketch here. Basically we're just drawing the sine curve between pi over 6 and pi over 3. So that's between 30 and 60 degrees. And sine goes from 0 to 1 between 0 to 90, doesn't it? So like that. So the curve in principle is going to look like that. That segment. And then we come down here, don't we? And basically this is the region R. Here. So this is R, and we need to find the volume generated when this is rotated through 4 right angles about the OX axis. So we're going to generate a cylinder, a series of cylinders. It's going to become a volume, isn't it? And basically this is a cylinder, and we can label it as volume delta V, where that volume of that cylinder slice is, well, the thickness is of delta x, and the radius is of height y, isn't it? So it's pi r squared as a cylinder. So pi r squared is pi y squared times the thickness delta x. So there's our volume then. Is equal to the integral, sum all these slices between pi over 6 and pi over 3 of the pi y squared dx's. So we write it like so. So that's what we need to work out then. So that's equal to pi over 6 to pi over 3. Pi we can put at the front there. Pi lots off. Y squared is sine squared. So there's our integral. We're going to need to use a double angle formula. So cosine 2x, if we remember, is equal to 1 minus 2 sine squared. So move the 2 sine squared over. 2 sine squared x is equal to 1, and then move this over the other side, 1 minus cosine 2x. So it'd be better to put a 2 in here. So I'll put a 2 underneath. 2 over 2 is 1, so I haven't changed anything. And now we can just write pi over 2. The integral between pi over 6 and pi over 3 of the 2 sine squared, which we can replace by 1 minus cosine 2x. Now we just integrate. The cos 2x is a function of a function. The integral of 1 with respect to x is x. Minus, this will integrate the sine, won't it? And when you differentiate sine of something, you get cos of something, which we've got, multiplied by the something differentiated, which is 2. We haven't got a 2 here, so we'll need to put a 2 underneath. The minus will need to be also kept, because sine just goes to cos. So there's our integral then. We've got pi over 2 outside it, so don't forget that. It's easy to forget. Pi over 3, pi over 6. So we've got equal to pi over 2 then. Top value is put in pi over... I've got it round the wrong way here. Pi over 6 and pi over 3. So top value pi over 3. Put that in here and put it in there. 2 pi over 3 minus a half sine 2 pi over 3. That's the top value minus the bottom value, which is put the pi over 6 in, minus, and then put that in there. 2 pi over 6 is pi over 3, so it's minus a half sine of 2 pi over 6, which is just pi over 3. Close that bracket, close the square bracket. So that's equal to then pi over 2. Right, what have we got then? We've got pi over 3. There. Take away pi over 6. And then we've got minus a half sine 2 pi over 3. And then we've got minus this, which is a plus, when we run the minus through the bracket, half sine of pi over 3. So we need to tap this in the calculator then. The pi over 3 minus pi over 6, we can work out if we wish. I'm just going to leave it as is for the moment and just work it out. So it's pi over 2 then. Pi divided by 2 times bracket pi over 3, so let's just type it in, doesn't do no harm, minus pi divided by 6 minus 0.5 is the half times sine, and we need to be in radians mode, which we are, 2 pi over 3, 2 times pi divided by 3, close that bracket, plus 0.5 again times sine of pi over 3. Close that bracket, close the bracket at the end, and press equals. 0. To 3dp 0.822. And that was to 3 decimal places.